In Chapter 9, Part 3, we are going to start by graphing systems, and we're going to start with looking at a line in number 36. So we want to identify our y-intercept, which is our 3. So we are going to plot that point on our graph. Our slope is going to be negative 1 over 2. So we're going to go down 1 unit over 2 to the right, down 1 over 2, down 1 over 2. I apologize for my points. So we're going to have our line. So in number 38, we have y is less than negative 2x plus 2. We are going to start the same way. We are going to plot our y-intercept, which is a positive 2. Then we're going to use our slope. We're going to go down 2 over 1, down 2 over 1, go up 2 over 1 over here, and we're going to draw our line. So once we plot our points, we are going to look at our inequality symbol, which is less than. So since it is a less than inequality, we are going to represent this with a dotted line at our points. So it means that we are not including those values. So it's a less than symbol. So what we're going to do from here is we are going to pick a test point. So anytime you graph an inequality, you must shade. So a test point is something that you could plug in to see if it's true or false. I always use 0, 0 if the inequality is not crossing that point. So if you look here, 0, 0 is underneath the line, so we can use that. So you're going to plug 0 in for y, 0 in for x, back into the original inequality, and see if it is true or false. So 0 is less than 2. Since that is true, we are going to shade where that point is located compared to the line. So because the point is located beneath, like below and to the left of that inequality, we are going to shade in that area. So anything in here, we could plug in any x and y value back into the original equation and it would work out. Okay, so taking a look at 39, before we can do anything, we have to get this so that y is by itself. So we're going to subtract x on both sides. So 2y is less than negative 2 minus x, and then we'll divide every piece by 2. So y is less than negative 1 minus 1/2 x. So we can plot our y-intercept at negative 1. We're going to go down 1 over 2 each time. So we can plot those points. And then we're going to draw our line. So before we draw it, we want to see, is this dotted or solid? So if it is less than, it is a dotted line. So we are going to have our dotted line through our points. And now we want to test a point. So again, I always use 0, 0 as my test point, which we can use in this case because 0, 0 is not on that dotted line. So I'm going to plug 0 back into the equation, and you could plug it into the original or into the new equation. It doesn't matter. I'll plug it back into the original. So 0 plus 2 times 0 is less than negative 2. So that becomes 0 is less than negative 2, which is false. So since that is false, we are going to shade in the opposite area. So because 0, 0 is above the dotted line, so 0, 0 is right here. Because that's false, we are going to shade on the other side of our dotted line. So everything below that dotted line would satisfy that inequality. So in number 40, we are looking at a systems of inequalities. So we're going to start, I'm going to use purple for my first inequality. I have a y-intercept of 5. So I'm going to plot a point, and my slope is negative 1. So I'm going to go down 1 over 1, down 1 over 1. And if I look at my inequality, it is less than or equal to. So this is going to be a solid line. I apologize for my terrible line. The second inequality I'm going to do in blue has a y-intercept of negative 1 and a slope of 2/3. So I'm going to go up 2 units over 3 and put a point. up 2 over 3, go in the other direction. And this is going to be a dotted line because it is greater than. So we're going to pick a test point, and again, I'm going to use my standby test point, which is 0, 0. So if you look at the graph, 0, 0 is at the origin, which is not on either of those lines. So I'm going to plug 0, 0 back into the purple equation. So 0 is less than or equal to negative 0, which is 0 plus 5. So 0 is less than or equal to 5, which is true. So that means since 0, 0 is, at the origin and it is below my purple line, I'm going to shade the purple below that line where 0, 0 is located. For my blue line, I'm going to test the point 0, 0. So 0 is greater than 2/3 times 0 minus 1. So 0 is greater than negative 1. That is also true. So compared to my dotted blue line, 0, 0 is above. So if it's true, it's going to be shaded where that point is located. So I'm going to shade above my blue dotted line. So what happens is we have a bunch of things going on, and this is why it's important to use different colors so you can see where the shading is overlapping. So I'm going to actually make that green. So where it's all overlapping, which is going to be in this section right here, is where you will find the solutions to your systems of inequalities. So anything in this green area would satisfy both inequalities. So when you go to shade it, make sure you make that darker or somehow highlight that so that you know that that is where the solution is going to lie. So we're going to take a look at part C. So I'm going to graph my first inequality in green. I have a y-intercept of 2 and a slope of up 1 over 2. And this is going to be a solid line because it is less than or equal to. I'm going to graph my other line in blue. So I have a y-intercept of negative 3 going down 2 over 1. I can also go up 2 over 1. And this is going to be a dotted line because it is less than. So now I'm going to test a point, and similar to what I've done in the past, my test point is going to be 0, 0. Because if I look, 0, 0 is right here, is not on either of those lines. So I'm going to plug 0, 0 back in for my green line. So 0 is less than or equal to 1/2 times 0 plus 2. So that would become 0 is less than or equal to 2, which is true. So since my point is below my green line and it's true, I'm going to shade below my green line in green. Now I'm going to test my other point, my other line, my dotted line, my blue one. So I'm going to plug 0 is less than negative 2 times 0 minus 3. So 0 is less than negative 3. This is false. So we are going to shade on the opposite. So 0, 0 compared to my dotted line, as said, is right here. So since this is false, I'm going to shade on the other side. So everything to the left of my blue dotted line would be shaded. So again, we're looking to see the part that's overlapping, which I'm going to make in purple. So I'm looking to see where are the two colors overlapping, and that would be the solution area for these systems of inequalities. So in this purple area, we could find answers for both of those. The last example we're going to look at is D. And we're going to start by graphing x is less than or equal to negative 3. This is a vertical line at negative 3. So we are going to have a solid vertical line. I'll try my best to draw as straight as I can. And then in blue, I'm going to graph my other line. So I'm going to start at positive 2. And I'm going to go up 5 over 3, which I will run out of space. So I'm going to go down 5. 1, 2, 3, 4, 5 over 3, 1, 2, 3. And this is going to be a dotted line. So we need a test point, and I'm going to use the same one, 0, 0, because here is 0, 0. Neither of those lines are crossing at that point. So I'm going to plug 0 in for x and y in the first inequality. So 0 is less than or equal to negative 3, which is false. So since this point here is false, I'm going to shade on the other side. So everything to the left of my green solid vertical line will get shaded. My blue line, I'm going to plug 0 in for x and y. I will get 0 is less than 2, which is true. So that is a true statement, and since 0, 0 is below my blue line, and it's true, I'm going to shade where that blue line, where that point is going to be located. So again, you're looking to see where are these overlapping. And it's just going to be this small little corner triangle here that they're going to share a solution.